Hello, I am the young physicist, and today we are going to do the problem 1.3 of IRODOV. A car moving rectilinearly, first with acceleration a equals to 5 meters per second square, the initial velocity is equal to 0, then uniformly, and finally decelerating at the same rate a, comes to a stop. The total time of motion equals to tau equals to 25 seconds. The average velocity during that time is equal to 72 kilometers per hour. How long does the car move uniformly? So, there are actually two solutions to this problem. The first one I'm going to do first is the easiest, and the second one is just a little bit harder because you need to manipulate some mathematical equations, but I will do that first and then I can do the second. So, this one we are going to do by the concept of average velocity and analyzing this graph. We know that the average velocity is equal to displacement upon total time. Analyzing this graph, the displacement is just the area under this graph, okay? And the total time we know from the equation, that is tau. So tau equals to average velocity is equal to, what is the displacement? It's the sum of the distance covered by the first part of the motion plus the second part plus the third part. Why? Because the object starts from the rest. The distance is 0 at the beginning. So the final position is just the sum of the positions. The first part of the motion, the displacement of the first part is equal to 1/2 a t squared, where t is this time of the first part of the motion. The second part is just at plus tau minus 2t plus 1/2 a t squared. So analyzing here, this part of the equation is the distance covered by this first time of the graph. This other part is the distance covered by this part of the graph, and this last part is the distance covered by the last part of the graph. All these equations using kinematics notion. So here we have that equation S is equal to S naught plus V0 t plus 1/2 a t squared. But in our case, S naught is 0, V0 is 0, and 1/2 a t squared is just here. In the second part, there is no acceleration. When there is no acceleration, the distance is just velocity times t. What is the time? Tau minus 2t. What is the velocity? It's just at. That is the velocity it accelerated from this first part of the graph. So here we have at is this velocity. And the third part is just the same as the first, as we talked in the beginning of the video. So erasing it here, we will have tau, let's put in red, tau times average v is equal to at squared plus 2at tau minus 2t plus at squared. I just multiplied the whole equation by 2. So 2 tau average velocity is equal to 2at squared plus 2at times tau minus 2t. We can cancel the 2 that we multiply, and now we can put at in common. Tau average velocity v is equal to at that multiplies v plus tau minus 2t. So tau average velocity is equal to at that multiplies tau minus t. So we have tau, we have average velocity, we have a, and we want to find t. So tau equals to 25 seconds, average v is 20 meters per second, so here is 20. This is equal to at, where a is equal to 5, times 25 minus t. We can cancel 5 with 25 and this becomes a 5. 5 times 20 is equal to 100. So 100 is equal to 25t minus t squared. So with this equation, let's put that here, we have t squared minus 25t plus 100, it is equal to 0. We can rewrite this equation like that way. T squared minus 20t minus 5t plus 100. This is equal to 0. Now we do the following. T that multiplies t minus 20 minus 5 that multiplies t minus 20 is equal to 0. And we can group again. T minus 5 multiplies t minus 20, that is equal to 0. So as you can see easily, the two roots of this equation is 5 and 20. So the 2 times is 5 and 20. Which is these 2 times? It's here 20 and here 5. So what is this velocity at? Is 5 times 5, 25 meters per second. And what is the time that the object passed this part of the motion? It is just 20 minus 5, that is 15. So if we want how long does the car move uniformly, it is just 15 seconds. That is this time minus this time. So the answer is 15 seconds. It's just one time minus the other. So it is the first part of the question. We have our first solution. We can do by this way, and we can do by the other way that we show to you now. The second solution is just a more general way to solve this problem. We will have an expression instead of a value in the end. So let's sketch the graph again. V for t. The graph is trapezoidal. We can divide it again here and here. We can call this T1, this T2, and all of this tau. We can call this velocity here V0 and do the following. We know that average velocity is going to be equal to 1/2 AT squared, where AT squared can be written as V0 times T, as A is equal to V0 upon T, and the T squared, they squared cancel out with 1T, plus V0, this is T1, V0 times T2 minus T1 plus 1/2 V0 times T2 minus T1. I mean tau minus T2. So we can write by this way. And we can pass the tau multiplying. So 2 average V tau is equal to V0 T1 plus 2 V0 T2 minus T1 plus V0 tau minus T2. So 2 average velocity tau is equal to V0 in common is V0 that multiplies T1 plus 2T2 minus 2T1 plus tau minus T2. So 2 average velocity tau is equal to V0 that multiplies, here we have T2 minus T1, T2 minus T1 plus tau. I am going to define T2 minus T1 as T0. It's just a definition. This will be our first equation. The second one, we write the following. We have that A is equal to V0 upon T. That is just delta V upon delta T. This first part of the equation. That is also equal to V0 upon tau minus T2, as this time is equal to this time. So T1 A is equal to V0 tau minus T2 times A is equal to V0. We have these two equations, and we need by somehow relate this part of the equation with these two equations. So we can do tau minus T2 is equal to V0 upon A. Therefore, minus T2 is equal to V0 upon A minus tau. We can sum T1A V0 with minus T2 equals to V0 upon A minus tau, and we will get the following. T1 minus T2 is equal to 2V0 upon A minus tau, where T1 minus T2 is equal to minus T sub naught. So T naught is equal to tau minus 2V0 upon A. And then solving for V0 is equal to tau minus T0, all of this multiplied by A upon 2. So this is our last equation, and we just need to put that here in the first equation. So let's erase this graph that we won't use anymore and do the following. We have 2 average velocity times tau is equal to V0 times T0 plus T tau, and we have that V0 is equal to A upon 2 times tau minus T0. That's our second equation. So in place of V0 we can put this V0. So 2 average velocity tau is equal to A upon 2 times tau minus T0 times T0 plus tau. You can see what is this? This is A plus B times A minus B. So 2 average velocity tau is equal to A divided by 2, that multiplies tau squared minus T0 squared. That is just a factorization. So for average velocity tau is equal to, divided by A, is equal to tau squared minus T0 squared. So passing to the other side, T0 squared is equal to tau squared minus, for average velocity, tau divided by A. Finally, we have our answer. We just need to put our tau in common and square root from both sides, and we will have T0, that is how long the car moves uniformly. So I'm going to erase this second part, we won't use anymore, and we will have, if I put tau in common here, T0 is going to be equal to square root of tau that multiplies tau. I can actually put tau squared in common, it's better, because by this way I can put the tau here outside. So if I put t squared in common, here will be a 1, here a minus, here will be 4 average velocity A tau. Let me see if it's everything right. I believe it is. Tau squared minus 4 average velocity T divided by A. Yes. This is the general equation. And as you can see, if you put the values here, T0 is going to be 15. Let's test. Tau 25, square root of A5, tau 25, so 5 times 25 is 125, minus 4 times 20, that is 80. All of these divided by 125. This subtraction is 45, so it is equal to 25 square root of 45 divided by 125. That is equal 25 square root of. That is 9 divided by 25. That is equal to 3 times square root of 35. That is equal to 15 seconds. So as you can see, the answers are the same. This is just a more general solution. You have just the variables and you could just insert the values of the question and you get the answer. So as you can see, these parts were a little bit more difficult. There were just some manipulations with mathematics, but we get into our answer. You just may choose between the two solutions I showed you, and good luck. See you in the next problem. The next one will be 1.4. Hope you enjoyed. If you enjoyed, like the video, share it to your friends because it's really important. And if you have any suggestions, just comment below and I will consider. Thank you.